clap one time.
Awkward scene instead of the reason everything.
You can hear me clap 2 times. You can hear me clap 3 times. So you guys right now have 3, you should have 3 pieces of paper. So first hold up the one that has the graphs on it. At the end of class. Hagar, find the one that has graphs on it. Jesus, find the paper that has graphs on it. So, Natalie? Yeah, there you go. The images. All right. So that's the one that we're going to start out with. Next, hold up the green packet. And put your name on it. So we're going to do 4 parts of a lesson today that are going to help us address these goals, which I'm going to go over a little bit more after we're done with the entrance question. And then hold up the 3rd piece of paper that has a graph on one side, and it has a chart with some names of different representations on the other side. And that one is going to be independent work / homework, depending on how far we get in the lesson today. So this last one that German's holding right here, write homework / independent on this one. Yeah, you do. This. All right, and then I'm going to project some statistics that are taken from the National Highway and Traffic Safety Association. They're the same ones that you guys have on your paper. So go back to the first paper that you had that says entrance questions on the back, and then it has some histograms on the front. One's kind of a histogram, one's more of just an infographic. And then can everybody put their finger on the word entrance question? And then Natalie, can you read the entrance question?
Yeah. What conclusion can you draw from the following data collected reported by the National Highway Traffic Safety Administration?
Oh, and you can cross out that word at and change it to and. So the data was collected nationally, and it's being reported by this organization nationally. So on the back, you have the data, and right now I'm going to ask you guys to look at that data and see what conclusions you can draw from those graphs, and then I'm going to ask us to share out some of the conclusions that you're coming up with. So I'm first going to give you a minute to just consider the data by yourself, and then I'm going to give you 2 minutes to discuss and write. So go ahead and just look at the graphs on your own first. All right, then please turn and talk to the person or people next to you and tell them some of the things you're noticing. And I'm going to put another 2 minutes on the timer, and then we'll share out the different conclusions that people are reaching.
That 16-year-olds crash more than everyone else. Better way to say that is, at age 16, you're more likely to get in a car accident.
When you're done talking, please flip over your paper and record your ideas.
The other way is,
And as you can see, furthermore,
So what did you guys notice?
The ages, it shows from the.
no, I did not.
You weren't saying anything. Hold on.
Yeah, I did. I noticed
This is about the fatal crashes.
By the
and
time the age changes to higher, they become more mature and they crash less.
Oh, okay. Interesting. So why don't you write that on the back? See if you can think of some data that is going to... Jesus. What data can you write down that's going to support what you just said to me?
That by the time they're more mature, they crash.
What do you guys think?
Can you stop? Just stop.
Nice. The newer the driver, the more likely they are to crash. All right. I'm hearing a lot of discussion about the first histogram. Look at the infographic also. The bottom one, and see if you can make sense of the bottom infographic. What is that telling us? How's it like the top one? How's it different than the top one?
that, oh, it's like the top of the
Wrong side of the road. Like, on a freeway, like the wrong side.
Excuse, sorry. I can smell it.
All right. 3, 2, 1.
Focus.
So this website's actually working really slowly. I was gonna project the exact graphs that you guys have, but I'll just use one of the papers on the document camera for right now, since it's working slowly. Malik, do you mind putting the screen down? All right, so I'm gonna steal Emily's paper right here, and then let's start out with this one. What kinds of conclusions could you guys draw from looking at that top histogram? What's going on with that? Samantha?
That 16-year-olds are more likely to get into a car accident.
What's your evidence for that?
The arrow for the 16-year-old are, it says 61.4, which
Okay.
is higher than the other ones.
All right. Antonio?
I think it shows that the newer the driver is, the more likely the driver will crash.
The newer the driver, the more likely the driver will crash because
Because the number of crashes keep going down as the age increases.
all right. As the age decreases, the age increases, the number of crashes decreases. Jesus?
That once, like, when they're usually, it shows that at age 16 more people crash, and as they started growing and becoming more mature, they crash less.
Okay. Annabelle, what did you say?
No, never mind.
We got it? Okay. We're going to move on to the second graph then, which is a little bit hard to see, but you guys have it in front of you. So what's going on with this one? What do you guys notice about this one? What can we conclude from the bottom graph? How about?
that unsafe speed is the most fatal car crash causing many drivers.
Can you repeat that one more time louder?
That unsafe speed is the highest fatal car crashes out of all of them, of like signals, alcohol, drugs, passing, lane change, on side of the road.
All right, so of all the causes listed there, the rate is highest for unsafe speeds. All right, any other conclusions that people were drawing? Hi, Gar.
It shows that all the causes that teens crash mostly in, and it shows a percentage on the most. Like unsafe speed got the most, and other is like the less.
All right, so the other causes has the least percentage, and the unsafe speed has the highest percentage. Can you guys, I'm gonna give you another minute to talk to the people around you. How is the first image different than the second image? And I'm not talking about just like the arrows and stuff. How's the math in the first graph different than the math in the second graph? What distance or what differences do you notice between the top one and the bottom one? All right, so take about a minute to talk about that, and then we'll check in.
And this one, just numbers.
The second one is ages 16 through 19, not everyone, but yeah, I agree.
No, they go.
I have a pimple on the side of my head.
Okay, there we go.
The second one shows the reasons why they get in crashes.
No? Oh, yeah, I get it.
Ages 16 through 19.
Yes. No, don't add to it.
We can check in.
You should put a sticker on it like. Okay.
All right, 3, 2, 1. Focus.
Okay.
All right, so what would be a good name for the top graph? What should I call the top image? So when we're talking about them, we can distinguish between them. Cassie, what should I call the top graph? Fatal crashes. Why do you think that would be a good way to refer to that top one?
Because it talks about the age groups, about the percentage, about how much fatal crashes that age group has had.
Okay, so fatal crashes by age group, maybe? And then I'm just going to write down that you said the word percentage over here. So I want to see what people think about that. And then how should we refer to the bottom image? What would be a good name for the bottom image? What's it talking about there? You said? Reasons for fatal crashes or causes for fatal crashes? All right, sounds good. Reasons for fatal crashes. All right. So what do you guys think? Compare and contrast those two images. What do we notice is different about the math in the top graph versus the math in the bottom graph? I heard some good statements while people were talking before. Annabelle, what can you tell us?
In the first graph, it's out of like a random selection of 1,000 drivers in the age group, and in the whereas in the second graph, it's just out of everyone that they know of.
All right. Christina, I'm going to ask a question and tell me if you're ready. If not, I'll come back to you. What does she mean out of 1,000 drivers? Why is she saying that this one's different because it's out of 1,000 drivers? They only test 1,000 drivers? Okay. Do you guys agree with that? That they only tested 1,000 drivers in this case? Okay, that's a good. I'm glad that people are surfacing that. Samantha, what were you gonna say?
Out of every age group, like out of 1,000 in every age group.
No.
Right?
Out of 1,000 in every age group.
Yeah.
Okay, so 1,000 16-year-olds, and then we have a result for it. 1,000 17-year-olds, and we have a result for it. 1,000 18-year-olds and 1,000 19-year-olds. Okay, so I want to clarify something, and I'm glad that Christina said that, because this is national data. So this is for the whole country. So they took statistics about the entire country, and then why do you think they would reduce it down to 1,000 drivers? Annabelle, what do you think about that?
It's easier to understand, and then also it makes more sense because if there is like a bunch more 16-year-olds, let's say, than any other age group, then it would be not right data because you're taking too much of one and not even amounts.
Okay, so they survey the whole country, and then 1,000 makes it easier to understand, and it also makes the group sort of even out. So we're thinking of this number 1,000 for all of them. Okay, I want you guys to, one more time, check in about the reasons for the fatal crashes. Everybody, remind yourselves of what you said about that bottom part. What's the bottom graph talking about? So turn and talk to your partner about that bottom graph again. What is that telling us?
The amount of a specific reason of why teams get crashed.
Out of 16 to 19. And that's not what I meant. I mean like 16 to 19. Yeah, okay.
That's why I called it that.
Okay,
I know, I'm
3,
like,
2, 1.
Oh, I get it now, but
I'm gonna ask Marbella to repeat what you just said because it made total sense. Can you say it again? Hold on, not everyone's there. Go ahead.
The second one's talking, it's giving a percentage of a section of that can cause or happen in a car accident.
Yeah, and what I heard you say is causes of crashes. It's giving a percentage of crashes that happen for a certain cause. So this one's talking about drivers. Is this one talking about drivers over here?
No.
So I'm going to erase the word everyone. measuring? You said everyone like people, but did you actually mean people?
I meant like out of everyone by not. They didn't pick random people. They meant like they surveyed lots of people in a certain age group.
Okay, so they did survey a lot of people all over the country. But what is this measuring in the second graph? Karis?
16 to 19-year-olds, the percentage of how they could get into car accidents.
Yeah, how did they get into the car accidents? So this is actually talking about the reasons for the crashes out of all the crashes. So the top one is talking about the drivers. And the bottom one is talking about if we consider all the crashes, if we were to sample the police reports of all the crashes, what percentages of those crashes happen for the certain causes. Okay, so I just want to make sure that when we're working today, everybody's clear that this one's talking about drivers. How many drivers in each group had a fatal crash? Whereas this one's actually talking about if we consider all the crashes, how many were caused by a certain thing, by a certain unsafe driving behavior. Okay, so right now pick up your green paper. And everybody put your finger where it says part 1. So part 1, is there a volunteer who wants to read? All right, Jeremy, go ahead.
How can we represent statistics to make them meaningful? Consider each of the following statistics, report the given percentage, and then represent it into
Okay, so today what we're going to do is look at these numbers that we have in front of us and try and make them make the most sense in terms of drivers and their age, and also crashes and their reasons. So we're really trying to think about what's going on with the actual numbers. So we want to represent these statistics in more than just one way. And you guys have a lot of experience looking at a percentage and representing it in a lot of different ways. And we want to think about how that could help us understand who's crashing and why they're crashing. So that's the first thing. After we're done with that, we are going to think about different ways that we can represent the proportions of people crashing and how those different representations of proportions could help us to understand what's going on if we change the sample size. So those are our 2 goals for today. So if we go back to looking at this, I heard earlier someone say that these are percentages. So I want to see if you guys agree with that. And to help us decide if we agree with that statement, let's look at these sentence frames. Can everybody read the first sentence frame we have right here? Go ahead, 1, 2, 3. Okay, so let's look at the 16-year-olds. Everybody flip over your paper and put your finger on the graph that has 16. What's going on with the 16-year-olds? Somebody choose a sentence frame. Actually, everybody. I'm going to have you guys choose one of the sentence frames and then say it to your partner, talking specifically about the 16-year-olds. I'm going to listen while you're doing that, okay? Go ahead. Choose one of these and talk about the 16-year-olds. Go.
For every 1,000 drivers, there would be
1,000 drivers?
61
I don't think that's right. I don't think that's right, Samantha. For every, I think we're only talking about the 16-year-olds.
That's why.
You said every driver.
For every
So what's going on with the
1,000 drivers.
61.4?
I think we're only talking about 16-year-olds, not
Let
every
me finish
single
the sentence.
For this
Racial
one,
language.
for this one, Portugal or for this one, we're talking about. So,
Yeah, she's talking about every single driver. I'm just talking about 16-year-olds. Are you talking about 24-year-olds, 30-year-olds?
How does that
Let
fit
me
into the
finish the
sentence frame?
sentence and maybe we'll
Okay,
start
say it.
talking about 16-year-olds.
there would be 61.4
See, you're not saying things like you have anything to say.
crashes.
I said then say it.
Out of every how many? Nice.
Okay, stop talking about dogs.
Did you guys get a chance to say it?
Would you say?
looking at the 61.4, how can you put it into one of those sentence frames?
61.4 out of every 1,000. No, out of 1,000. Because you switched it.
Yes.
You said for every 1,000.
Can you participate once in the
What you meant?
For every
All right, 3,
1,000 drivers
2,
for 60
1.
minutes. Focus.
All right, what are some statements that you guys came up with? Gia, do you have one that you could share?
Yeah.
Okay, let's hear it.
There would be 61% of 16, no, the fatal crashes caused by 16.
Okay. 61% of fatal crashes are caused by 16-year-olds. So which sentence frame were you trying to use?
There would be,
So down here?
yeah.
Okay. So this sentence frame goes all together. For every blank, blank, there would be blank, blank. So for every what?
For every,
I'm going to give you a second to think about that one. Can you guys skip this sentence frame right now while Gia thinks about it? And then tell me about one of these. How could you use one of these? There, you had a good one. Can you tell me what you said? Go ahead.
61% out of every 1,000.
Okay, 61% out of every, what'd you say? 1,000 16-year-old drivers, right? Have been involved with a fatal car crash? Okay, so I heard this statement all over the room. Is there anyone who disagrees with this statement? Yusuf, what do you think? 61.4. Do you agree with the percent? You're being a little more precise. And you would erase this percent? What does percent mean?
No, see, I disagree.
Annabelle, do you agree with Yusuf?
No,
What do you think?
because isn't it more than half? For this, it's because 61 out of 1,000 isn't more than half. And then if you erase the percent, then it's just 61. Oh, I could be wrong. Never mind. It's okay.
If you guys look at that image, do you see the percent symbol anywhere in that image? All right, Antonio, what were you saying?
Like there's no percentage, and on the bottom one, the caption says percent of fatal injury crashes, and the top one, it doesn't say anything about percent.
Okay, so you just said something super important. This is actually not a percentage because of what Yusuf said. A percent is what?
Out of 100.
Out of 100, right? So if it's telling us 61.4 out of 1,000, what if we wanted to change that into a percentage? So I'm going to use the specificity that somebody said of adding the tenths in here. So 61.4 fatal crashes are to be expected
It's a 0.4 of a person because of the crash.
out of every 1,000 16-year-old drivers, right? So if we want to change this from being not a percentage, because a percentage is out of 100, and we want to change it into a percentage, what would we have to do? What would we adjust to make this out of every 100 instead? Everybody tell the person next to you.
You would ask Miss Swandby.
Wait, we have Sandra.
I think it's harder. Hey, do you to make this equal?
No, I thought.
Jesus, you have an idea? All right, I want to keep us moving so you guys can get to the part where you're moving stuff around and working with the sort. So can somebody tell me, how do we do this? If we have 61.4 out of every 1,000 16-year-old drivers and we want to change it into a percentage, what do we have to do? Cassandra?
Divide by 100.
Okay. We're going to move from 1,000 to 100, so
By
we
10.
divide by 10.
Yeah.
So then what does that do to this number over here?
You divide by 10.
So Malik, what would you get? 6.14. So if we're considering 1,000 16-year-old drivers, and then we're changing it to 100 16-year-old drivers, that's changing the sample size. So our sample size was 100, and then was 1,000, and we just changed our thinking to consider 100 people instead of 1,000 people. So that's what we're going to do next, is think about if you change the sample size, how does that change the expected occurrences? So we would expect here 61 people, approximately 16 years old, to have a fatal involvement somehow in a fatal car crash, right? Here, we'd only expect 6.14. Can anybody think of one more change we can make to the sample size and then tell me the corresponding occurrence that you would expect? Nayar?
6.4.
All right, so if we go down to 10 drivers that are 16-year-olds, we wouldn't even expect for one of them to crash. We'd expect for a little over half of them to crash, which is kind of illogical. Why do you think they didn't list it as out of 10 drivers? They listed it out of 1,000 drivers. Annabelle?
Because it made the most sense, because you can't imagine a sixth sense of a person like getting in a car crash.
Yeah. All right, so what you guys just did is you changed the sample size in 3 ways. Right now I'm going to ask you guys to do the same thing for choose either 18 or 19-year-olds and then choose 2 of these and write that statistic in 2 or 3 different ways. I'm going to give us 5 minutes for that, and then I'm going to project some of the ways that people rewrote those statistics. Can somebody restate what I just told you to do? Malik?
So do the 18-year-olds and
What?
Choose either 18 or 19-year-olds and rewrite the sample size. You don't have to use 110. You can choose whatever sample size you want. And then down here, choose 2 of the different causes and figure out how you're going to rewrite that statistic. So I want you to rewrite these statistics in 2 or 3 different ways. Okay? So I'm going to give us 5 minutes, and then I'm going to put up some different examples for people. Go ahead. So how could you want to do 18 or 19? Okay, all ages is okay. Well, I have 18 or 19 on the paper, so choose 18 or 19.
I'll do 19. We'll do 19.
Okay, so think about other ways that you could represent 37.8 out of 1,000. So why don't you write that there first? So it's 37.8 out of 1,000, right? Mm-hmm. When you're done, talk to the person next to you about how you rewrote the statistics.
Wait, what? No. What? You're doing it wrong.
No, she said you could do any number. You just have to rewrite it. I'm doing it right.
Any number? What did you
Right?
I'm so
I don't even know anymore.
Oh,
Yeah, so you adjusted, so if the sample size were 2,000 16-year-olds, then you thought about how that would change the expected number of fatal accidents?
Yeah.
And then you adjusted to 200? Okay, why don't you use the same number as Samantha? So what if you change this to 2,000
I'm just wondering, like, this
people
is
instead
helping
of
me
1,000?
learn and visualize the 16-year-olds dying. Okay. If it was...
If I change what to what?
So you want to look at the 19-year-olds.
Okay.
If there's 1,000 19-year-old drivers, how
we do
many
2
are
or 3 here?
expected to crash?
I think we just do 1.
Or be involved in a fatal accident?
Miss Swandby? Do 1 or 2?
Only 1.
Oh.
right?
Yeah, so what did you write that? 37.8 out of 1,000.
Oh, out of 100, right? Oh,
What if you change that from 1,000 to 2,000? How would the expected deaths be affected?
Would this be the same?
Yeah, right, equals over 2,000.
Right, because that's out of 100. So if it was 1,000, it doubles.
So how would this number
60%.
be different?
Just
If this
do-
goes
just
from
do
1,000 to
on-
2,000, what's this number that's gonna happen?
Right? We just do like that.
Oh, you did it as a fraction?
Right? Isn't that how you're supposed to do it?
Well, supposed the other one was percent.
The other one's not percent, so there's
So then this would.
So what's the tough number?
Yeah. How about down here?
37.0?
8.
Oh, okay, 37.8, so then the next one,
What
if
if
you
you
move
look
it
at
over,
this 35%?
3.78.
What would that be out of?
Okay, so you get it? And then the next one is equal 10.
Why do you think it's
Equal. So you get it, you just move the decimal over once on every
Yeah,
number.
I agree. Why do you think it's correct?
You have no idea what. Okay, okay, right equal, the two lines. Right equal.
So if you change the sample size to 100 drivers, then what would you expect?
No, but you still weren't getting it.
I was equal sign.
I know. Came aware of that. It was down here.
I don't get how that was so funny.
I did equal and she did. It was a dog face?
Okay, I'm gonna pick up
did
with
it.
all the examples that I saw.
No, not like. Okay, then put a line over it. Over. No. Put a line over the. Okay. It's gonna take like 5 more minutes.
Can you put the screen down again?
The camera. Is that mine?
It's not.
Okay, 3, 2, 1. I'm gonna ask for everybody's pencils down and everyone looking at the screen. It's a little bit hard to see, so I'm gonna tell you what it says on the screen. So right here, Gia for 18-year-olds had said that if there's 1,000 18-year-old drivers, right now there's about 3 people who are not looking at the screen. They're trying to finish up and show persistence, but I need everybody focused on the screen. So for 1,000 18-year-olds, we'd expect about 45 of them to be involved in a fatal crash. Then she changed over here. She's got 50. So if there were 50 18-year-olds, she'd expect 2.27. So about 2 people to be involved in a fatal crash here. So Gia, can you explain? How'd you go from 45 out of 1,000 to 2-ish, 2.2 out of 50?
Because I, for 45.4, and then under, it was 1,000, I divided both of them by 10 to get 4.54, and then I put 100 underneath, and 100 as the denominator.
Mm-hmm.
And then I divided both of them by 2 to get 2.27 as the numerator and the denominator as 50.
Okay, so if I'm going to use the sentence frames, here you said for every 1,000 18-year-olds, there's 45 expected crashes. Here, for every 100 18-year-olds, there's 4.5-ish expected crashes. And then here, for 50 18-year-olds, we'd expect around 2 crashes. And you were more precise with your decimals, but sometimes when you're thinking about people, it's easier to round the decimals. All right, Samantha she went the other direction. So she went to a sample size of 2,000. So Samantha, do you remember, can you see your work up here? If we change the sample size to 2,000, how does that affect the expected crash rate?
Then the expected crash rate is
go up because
If the original one was 1,000, but the sample is 2,000, since it's greater than 1,000, the expected crash rate is going to be greater.
By how much?
2 times.
Yeah, how'd you know it's 2 times?
Because 1,000 times 2 is 2,000.
So if we increase our sample size to double, you could expect that the crash rates would also double? Okay. All right, flip to the next page.
1,000 times 2 is 2.
And then we're actually going to skip part 2 right now and go on to part 3. So skip over to part 3. And then can I have everybody put their finger where it says you have a bag? And then Catalina, can you read where it says you have a bag?
I have a bag with representation of 3 statistics from the NHPA report. With your partner, sort your cards and match them to a graph that represents a statistic.
All right. So everybody hold up the bag that's at your table. In that bag, there are cards that go together. They match because they're different types of representations of the statistics. Once you think that you have all the statistics put together into 3 separate groups, once you think you've matched them, then I'm going to give you a packet of graphs, and you're going to try to match each group to the graph. So I'm not going to give you more explanation than that. I'm going to see if we need more explanation as you start working. But right now, everybody should take out their yellow cards and start seeing what types of groups of yellow cards you can make. And Emily, I'm going to have you stood up here next to Maria.
Oh my god. Match them.
No, start working with the sword. All right, so do you guys understand the direction? What's supposed to be in your group?
50. So 200 is 70. So wait, I saw that.
This is for German, Maria, and Emily. So scoot down.
Okay. 20.
105 is this.
All right, so why don't you guys go ahead and start sorting those into the group. You need one of each of these things in each group.
105?
Okay, so you guys have these cards. Can you see German?
What would I pick up?
It should be 100.
So you want to work in their group or their group?
That'd be 5.
These guys? Okay, that's okay. So do you guys understand what you're supposed to do? What are you supposed to do?
Yeah, put the boys up there and
You think this one goes with these? Okay. Yeah, so keep going. So you're going to end up with 3 groups. There's going to be 4 in each group.
I can't hear you.
You can use the graphs now.
Oh, okay. For what?
Yeah.
Nobody's stuff in it.
Don't we have some?
Use the graphs now too. So take apart your graph.
Okay, well, I wouldn't know. With what would? Check the time like 3 times. See what these things are for. Because it's so sad. Remember that was like sleep.
All right, now Yoli, what's wrong? Did he take a break? How come you're having trouble getting started?
That's what we just said. Just agree to this thing.
Okay, so let's look at the graphs first. If you guys are having trouble getting started, you can go ahead and take apart your graph packet and start trying to match the cards to the graphs.
Oh, fair enough.
I'm gonna put another 10 minutes or so on the clock, and then in 10 minutes we're gonna make some sense of how you guys made your matches. Yeah, you can take your time. Yeah, we will fish. So.
Can I actually go
There were like 10 goldfish left.
Okay.
They were wrinkled.
How are we supposed to know this?
I only got a few down.
Is this the middle column? Oh, okay, then this has to go right there.
Oh, God, I love Costco.
Costco? Last time we caught on top of a bunch of bob. Now it's not the store for Costco, I see. Is this one right here or right here?
I don't know. This is still in the size of.
Oh.
How's she making those matches?
20.6.
Because that's the word column.
So you gotta look at it and
Because
figure out
1/5
why.
is 20.
And
And then you guys can also
And
fill in the
5 times
tables.
Well, how about
If
this
you
one?
made all
Because
your
it's a
matches,
7
fill in the
and
tables
20.
and see if they make sense with all the different parts.
Ah, that one there. So then this should totally go here.
just like the dumbest. Oh, so
You missing?
oh, then it's the voids right now. Cracking up.
All right, then when you guys think you have them sorted, match them to the graphs and see how they match with each of the graphs.
Thanks. No, I know what it really is.
You got my head stuck in the thing. And the at Christmas, what do you put on your door?
Does everyone have a graph packet? No, not right now.
There's no matches
All right,
with
take
this
this
one.
apart, and then once you think you have these matched, then try to match them to the graph.
And goes with this one. Cause with 5, here's 100, and then 5.
Yeah. What? What, Maria? What's your question? Okay, so let's check it out. So this one says if there's 10,000 or if there's 100 drivers, we'd expect 5 of something to happen. So does it make sense that if we go up to 200 drivers, we'd expect 70 things to happen?
Oh, really?
What if you go from 100 up to 200? What would we expect the occurrences to do?
Yeah.
5 by 200.
Why is that one there?
Well, how do you move from 100 to 200?
I'm multiplying 20.
100 times 20 is 200?
No. 92.
By 2? So if we have a sample size of 100, you think it's teens, 100 drivers, to go up to 200, I'm going to move around this side. You have to multiply that by 2. So what should this number be then in the table?
35. Oh yeah, because if you divide this by 2. We have that.
So to go from here to here, you said multiply by 2. So to go from 5 to this number right here, what would this number be?
50.
Why would you multiply by 50? So to go from here to here, we're going to multiply by 2. To go from here to here, yeah, this would be 10. So the choice that you made was 70 to 200. So 200 drivers, you'd expect about 70 occurrences. So do these match? Do you think those actually match?
No.
Is there one that matches better? All right, when you guys are done, choose one of the graphs and explain all the connections you made. So go ahead and write down how you made those different connections. How about if you went this way? How do you go from
we have to
100?
explain. We have to explain the graph.
Yeah. Why'd you match it to the graph that you matched it to?
Or why did we match these?
So for this one, I'm not sure I agree. Can you justify why these go together?
I got it. I'm gonna mess up again.
Okay. I'm gonna walk around, scan around, and try to. This is correct. Okay, I agree with B. So why don't you guys write about how you made the connections for graph B? So right here, start figuring out how you made the connections for graph B. If you can hear me, clap once. If you can hear me, clap twice. If you can hear me, clap 3 times. So we have about 4 more minutes until we share out. So right now, I need to do a scan of everybody's matches and see if there's any confusions that people... I need to just check and see if there's any confusions that people have in common so we can talk about those. But what I should see everybody doing right now is choose one graph. So choose, for example, graph B. And then there's a sentence frame right here that says, we knew blank went with blank because blank. So write your connections between the representations for just one of your graphs. Okay? So if you're done with your matches, I should see everybody writing on these green lines right now, explaining about one of your sets of matches. And I'm going to use this time to just check everybody's and see what you guys thought. Okay, so, yeah, I agree with these.
So, if we put, how are we going to make
I don't agree with these, so we're going to check these again. So let's just look at this.
How does any of these go with each other? Which ones? Are you doing these? Yeah.
Alright, I want you guys to just start out by matching the tables and these. So forget about these for right now. Try to just match those. Okay, so not sure about that one. I see why you have it that way, and I want you to look at it really close. I totally agree with this one, so you can take this one. So look at those really closely and see if you can figure out what it is that I disagree with about those. All right, so let's see. All right, so I agree with these.
She didn't get the, oh yeah, she didn't get the part.
I don't agree with all of these. I agree with this, this. Disagree with these. All right, why though? Can you figure out why? What does this say?
Because 120
Of x. So here's the x's here. So the x right here, the sample size is 100. What's a 20th of 100? 1/20th? If you split up 100, think about dollars.
Well, the decimal
Sample census frame, we know A went in with something because
Yeah, check these. All right, so you should be writing if you already are confident with your matches. Okay, so I agree with this one.
we skip part 2. So
There's something I disagree about, these. So keep checking those. Agree with this one. But these two are switched. Some stuff about these two are switched, so see if you can look really carefully at those.
what's the one?
I don't think one of these, please. How? Oh, wait.
Please.
And then whisper to like, guys. You can hear me.
Okay, if you can hear me, clap once. If you can hear me, clap twice. If you can hear me, clap 3 times. So, right now I noticed that almost every group except for like 2 made a really similar error. So I'm gonna save that discussion. And something that you guys all did pretty much was that you all matched graph C to the same sort cards. So what I'm gonna do right now is have people come up and share how you matched one of the pieces of representations to this graph C. So I need to see, first of all, I want everybody to stand up and stretch. Everybody stand up.
Let's give me some good footage.
And then when you're sitting back down, you're ready to listen and hear your peers and speak. Naomi, stand up. All right, here we go. 3, 2, 1.
Either way.
Okay, so someone come on up and tell us which statistic you matched. So what pair of words did you think went? Actually, I'm not going to limit you. You can bring up any of the pieces of representation and tell me how you knew it went with that graph. Zoe, why don't you come on up? Natalie, can you have a seat?
Yes, I was
Thank you.
fixing my graph.
Okay.
Well, what hours? For graph C, I did this one and these connected to the graph.
So I see the ratio is about 70 to 200, and then 7/20ths of x equals y.
The 7/20 times x equals y connects to about 70, 20, 200 because 7/20 times x represents 10. Because 7 times 10 equals 70, and 220 times 10 equals 200. So that equals 70 to 200. And this goes to 200 per second.
Okay, thank you. Can somebody come on, wait, leave those up there. Can somebody come up and add to what's already there? Nair, go ahead. And then touch the space bar to make it stop showing paradise.
This one, it matches to graph C because it shows, in the graph it shows 270, so 70, 200, and then 100 is with 35.
All right, I'm gonna give you a pencil really quick, and can you write in that 25, or the 35 that you just said? Do you guys agree with Nayar that the 100 and the 35 match up?
Yep.
Okay. So, thank you. So how'd you know that?
Because of the graph.
All right, so the x-axis was 200 and the y-axis was 70, and then you saw that the same point worked for 135. Okay, the last one. Ernesto, you want to share for the last one?
Yeah. That one?
Okay, so what does that say?
35.1 of fatal crashes among teens 16 through 19 are caused by unsafe speed.
Okay, can you guys just show a thumbs up if you agree that those representations all represent that statistic that Ernesto chose? Is there somebody that disagrees? Because there's some people that are showing thumbs up. All right, Ernesto, tell us how you knew that those were the words that matched up.
When I look at the percentage, 35.1,
I also saw, I took a look at the graph, and I saw that for each hundred, you get 35 expected occurrences, and I realized if I turn that into a percent, so if I turn this into a percent, like I turn each to a percent, that for each 100%, that you get 35.1 expected percent of expected occurrences.
Okay. Zoe, what were you going to say?
The 35.1 connects to the graph. It goes across. It goes to 100 and 35.1. But it's going in the middle of 30, 40.
Okay, so you can see the line on the graph shows that statistic, the 35.1. You say there's a dot in the middle of 35 and 40 around the place where it hits the 100. Okay, sounds good. So what you guys just showed is if we change the sample size, right? If we have 200 16 to 19-year-olds, we would expect that 70 of them would be in a fatal crash. If we went down to 100, we would expect that 35 would be in a fatal crash, and that matches up with our graph. What if we went to 50? How many of them would we expect to be in a fatal crash? Yusa. 17.5? Does that match up with the graph? So if I go to 50, we would expect this to be around 17.5? Does that look like it matches up?
Yeah.
Yep. Okay. Okay, if you can hear me, clap once. If you can hear me, clap twice. If you can hear me, clap 3 times. Alright, so here's the last thing I want to clarify. So when I was walking around, I noticed that this was a really common way that people matched up these representations. So you guys said that 20.6% of fatal crashes were caused by right-of-way errors. That's the same as about 10 to 50. So if we went from 100 to 50, that would change the 20% to about 10. And then people said that 1/20th of the x value was equal to the y value. And over here, most people said that 1/5 of the x value here was similar to a percentage of 5.1%. Does anyone know why I disagree with the way that these are sorted right now? So I disagree with something about each of the sorts. So turn to your partner and see if you can figure out what's wrong there. Why do we disagree with each of those, something about those sorts?
Because 1/20th, because this is technically, I think, this is 5 equals 5. I can't see it. What is she at, right? This is 100, right?
No, 10. No.
Because then this said what equals 5.
All right, 3, 2, 1. Is there anyone who can clear up the confusion? What's going on here? Why do I disagree with one of these? I'm going to hear from Cassandra and Gia. So Cassandra, what do you think? What's the mistake up here?
The 120 over.
Oh, so beautiful. Next field trip.
The 120x equals y, and 1 over 5x equals y. I think they should be switched.
Okay, you think they should be switched. Can you tell me why you think they should be switched?
Because 1/5 is like close to 20%, and then 120 is close to 5%.
All right, see if you agree with what she just said. She said 1/5 is close to 20%, and 1/20th is close to 5%. So she thought that those two things should be switched. Do you guys agree with that? Is 1/5 5%? No, right? 1/5 is close to 20%. Cassie, how do you know 1/5 is close to 20%?
Because it's like fingers.
What do you mean? Tell us about that. I totally agree. How do you use your fingers in that case?
20, 40, 60, 80, 100.
Okay, nice. So one of your fingers, each one represents 20, and then you get up to 100%. Gia, why do you agree with what Cassie just did?
Yeah.
Can you build on what she said? When you told me right now, you talked about the table. So how do you relate those two to the ratio table?
Oh, because 1/20th is the equivalent to 100 500ths.
1/20th is the equivalent to 500ths.
Yeah.
So, wait, 500ths?
No.
Is that right? 1/5?
20 hundredths.
20 out of 100 is the equivalent to 1 out of 5, right? It's okay. I heard you explain it really well to me just a second ago. Can anybody help Gia make those links between 1/5 of x resulting in this table, whereas 1/20th of x results in that table? Abel?
That if you look at where it says about 10 over 50, if you divide that by 10, it will be lower than it.
All right, nice. So 10 over 50, if you look at that, this would be close to 1 over 5, right? It would be equal to 1 over 5. Okay, so tomorrow I'm seeing that we still are going to need to check in a little bit about the link between the equation and the ratio table. But what you guys have done today is you've looked at statistics, you thought about how you could change the sample size, and then that is going to proportionally change the expected occurrences. For your homework tonight, you're going to choose one of these. Look at part 4, so flip to part 4. Nayeli, can you read part 4, the directions?
Make your own set of representation. Choose one of the following statistics and represent it with a ratio, like a ratio table, an equation, or graph. Consider how changing the sample size changes the expected appearances.
Okay, so when we look at this tomorrow, that's going to help me know if you're making the connection between what we did today with a new set of data. So what I need everyone to do right now is put their yellow pieces away in the bag.